Hey everyone, Praveen this side. I hope you guys are doing great. So today we are going to solve the problem add binary strings, which is a medium level problem. So the problem description says given two binary strings s1 and s2 consisting of only zeros and ones. Now find the resultant string after adding the two binary strings. That is, we have been given two binary strings s1 and s2, which only consist 0 and 1. Now we need to find the resultant string after adding those two binary strings. Okay, and there's a note point here saying the input strings may contain a leading zeros, but the output string should not have any leading zeros. That is, if our output has any leading zeros before any actual value, then we need to trim them off. Okay. So for first example, S1 is 1101 and S2 is 111. Okay. So the output is 10100. And here's the explanation that if we add these two numbers, we'll get this result. Okay. And similarly, for our example 2, the S1 is 00100 and S2 is 010. So since in S1 we have the extra zeros in the front, we are trimming it. Okay. So if we add 100 and 10, we are getting the output 110. Okay, so both the examples are clear, although I have not focused on explanation much because this is what we are going to do in our observations. So let's jump in the observations. So before moving to observations, we have a binary bit addition table here, where if we add any two bits along with the current carry, what is the sum generated and what is the next carry generated is displayed here. Okay. So here we can take any combination of bits along with their carry to see what is the sum generated and what is the carry generated for the next bits. Okay. So we'll be using this table to dry run our example. So here I have taken example 1 for dry running, okay, where S1 is 1101 and S2 is 111. Okay, so let's proceed our addition. Now generally when we do manually, how we proceed? We take last digits, then the second last digit, then the third last digit, right? So let's proceed the execution. Here we have bits 1 1, and since there's a no carry, we'll consider it as 0. Okay, so do we find any combination with 0 as a carry and 1 1 as a bit in this table? Yes, this is the point where the carry is 0 and the digits are 1 and 1. Okay. So what is the sum for that? The sum is 0 and the carry generated is 1, right? So we'll take sum as 0 and the carry generated is 1. Okay. Now at this place, the carry is 1 and the digits are 0 and 1. Okay. So do we find any combination here? Yes, this is the one. Here the carry is 1 and the digits are 0 and 1. So what will be the sum? The sum will be 0 and the carry will be 1. Okay. So the sum is 0 and the carry is 1. Now, the carry is 1 and both of the digits are 1. Do we find the same pattern here in the table? Yes, in the last row, the carry is 1 and both of the digits are 1. So, sum is 1 and carry is 1. Okay. So, we'll put sum as 1 and carry as 1. Now, till this point, the execution will stop because S2 doesn't have any more to contribute for the further execution, right? But do we need to stop the execution here itself? No, because we still have a carry 1 and a digit 1 here, right? So what do we do? Even when S2 gets exhausted, we still need to carry our calculation until we don't find any digit in S1 or we don't have any carry. Okay. So here we have a bit and a carry. And since here there is nothing, we can consider it as 0. Okay. So do we find any combination where the carry is 1 and the digits are 1, 0? This position, right, where the carry is 1 and the digits are 1 and 0. So what will be the sum? Sum is 0 and carry is 1. Okay. So we'll put sum as 0 and carry as 1. Now here our S12 got exhausted, right? But we still have a carry left. So do we stop the execution here? No. We still need to add this one in this calculation. Here the carry is 1 and both of the digits are 0, right? So if we look in the table, we find the combination at this place where the carry is 1 and both of the digits are 0. So what is the sum for that? The sum is 1 and the carry is 0, right? So the sum is finally 1 and carry is 0. But suppose the carry is not 0 and 1. Do we stop the execution here? No. We need to run execution until we have not exhausted S2 nor S1 nor the carry. Okay. So this is the point to be remembered. Now here our carry got 0 and S1 S2 both got exhausted. So this is our resultant string. Now if we compare this result with the actual result, here the result is 10100. and here the result is 10100. So we are doing good, right? But one thing to observe is that how can we remember this table, right? Like, do we really store the carry and the A B pattern in some data structure and fetch it? I guess we can do that, but that will become very tedious, right? Now I am going to share a trick through which if you have both carry A and B bit, then you can directly generate sum and carry, right? And it's purely based on observation. Now suppose if you're adding these two digits, then what is the sum we are getting? The sum is 2, right? Now if we modulo 2 by 2, what is the result we are getting? It will be 0, right? But if we divide 2 by 2, what do we get? We'll get 1. Now, which pattern we took? We took the pattern where the carry is 0 and both of the digits are 1 and 1, right? So, for carry 0 and both of the digits 1 and 1, what is the sum? Sum is 0 and carry is 1. That's what we got, right? Here we got the sum as 0 and carry is 1, right? Now, you might be thinking that this is just a fluke, that we got lucky here. Now, let's take another example. Now suppose if we have all the digits as 1 here. Now here the carry is 1 and both of the digits are 1. Okay. Now how do we get the sum and carry? For sum we need to do modulo 2 and for carry we need to do by 2 of the digit that we are getting. So here the sum is 3, right? So here the sum is 3, right? So if we do 3 modulo 2 we get 1, and if we do 3 by 2 we'll get 1, right? Now if we check the pattern where the carry is 1 and both of the digits are 1, which is the last row, what is the sum that we are getting? 1. And what is the carry that we are getting? 1. That's what we got here. Now maybe this can also be a fluke. Let's take the example where we have carry 0 and digits 0 1. Now let's take the example where the carry is 0 and both of the digits are 1 and 0. Okay. So if we add all of this, what is the sum we'll get? We'll get 1, right? So let me erase this. Uh, so the sum is 1 at both the sides. What is 1 modulo 2? 1 modulo 2 is 1, right? And what is 1 by 2? 1 by 2 is 0, right? So this depicts sum and this depicts carry, right? So the sum is 1. Are we getting 1 here? Yes, the sum is 1. So this is correct. And the carry is 0. Are we getting 0 here? Yes, the carry is 0. So basically, what you can do is add all the ones digit. Now, if you do modulo by 2, you will get sum. Okay. And if you do by 2 to the digit, then you will get a carry. Simple. So this way you can generate sum and carry without depending on this table, right? Now suppose let the resultant string be 0000101. Okay. So is this the correct resultant string? No, because in problem description it is clearly mentioned that all the starting zeros should be trimmed. So what we need to do? So we need to keep on checking that whether the starting digit is 0, yes, then trim it off. Then in the next digit, is it 0? Yes, trim it off. Next digit, 0, trim it off. Now finally, when we get 1, we need to stop it there. So we need to iterate and erase the first digit every time, right? But we can escape from this if we generate our result in the reverse order. That is, if we generate our result instead of this way, the reverse of it, that is 101,000, right? Then we can check at the back. If it is 0, we can trim, and at the back 0, trim, at the back 0, trim. Now finally here we have 1, so we can trim this off easily. Now what big difference will it bring if we compute our result in reverse way? Here, since we are iterating to each digit and erasing it, it takes the time complexity O of n square. But here we have our resultant array reversed. So we need to iterate and simply pop. So for iterating, it will take O of n only, right? But since we are popping the element, it will take the time complexity of O of 1. Simple. So this is one more observation, right? So what we need to do, we need to start the summation from ending, and we can calculate sum and carry, right? And at any point if string 1 or string 2 gets exhausted, do we need to stop the execution there? No, we need to write a logic such that if we have carry or s1 or s2 not exhausted, we need to continue generating the result. Okay. And after generating the result, we'll check, do we have any extra trailing zeros at the backside? If yes, then clean them up, and whatever result we generate, we can simply reverse and return it. Okay. So we have got all the observation. Now I want you guys to take example 2 into consideration and dry run from yourself, because if you dry run, you will get more clarity than what I am teaching here. Okay. So let's see the code. So here's the code in C++, although the logic remains same. So the function name is addBinary and they have passed two parameters s1 and s2. So initially I have taken both the sizes where n is s1.size and m is s2.size. Now after that I have declared two variables I and j, where I is pointing to last index of s1 and j is pointing to last index of s2. Okay. Then I have taken the resultant string. Okay. And the carry variable. And here we are running a loop till I is greater than 0 and j is greater than 0. Now it will satisfy the condition till s1 and s2 have some characters in it, right? I have declared a sum variable as 0. I am adding to the sum if s1 of I is equals to 1. If it is 1, then 1 will be added to the sum. And similarly for s2, I am checking if it is 1, then add 1. And here if there is any carry populated, adding that carry. Okay. Now after that, for sum, what do? We do modulo 2, right? So I am doing sum modulo 2 and converting it to character and appending it to result. And similarly, we need to generate carry for the next digit, right? So carry will be sum by 2. So these 2 points we have already looked. And after we populate this, we need to decrement both I and j. Okay. Now when we exhaust this loop, we have three scenarios. In scenario 1, we have some characters in S1 but nothing in S2. In scenario 2, we don't have anything in S1 but have something in S2. In scenario 3, since both S1 length is equal to S2, we don't have anything in S1 nor S2, right? So for the best case scenario, it's okay. But what for if S1 has any characters or S2 has any characters? So we need to cross check whether I is greater than 0. That means whether S1 has any extra characters. If it yes, so add that bit to the carry and append to the result by doing modulo 2 and equate carry by doing by 2. Okay. And decrement I. Now if S1 doesn't have, S2 might have some characters, right? So here while j is greater than 0, the same stuff. Now here too the same stuff where we are adding s of 2jth character to the carry and populating result and decrementing j. Now when we execute this both loops, right, we might have left with carry. So again, this is the third step that I told, that even if s1 and s2 get executed, if we still have any carry left, then we need to append that carry to the result. So that's what I am doing. So this was the step 1, this was the step 2, this was the step 3. And this step is the combination of step 1 and step 2. Right. So after we populate the result completely, this is the check where we might have zeros at the end, right? So we need to trim them off. So what I'm doing, while result is not empty, so that we doesn't trim on the empty result. Okay. And if result dot back is 0, then we are simply popping it back. So we are trimming it. Now after trimming, our result is ready, but in reverse direction, right? So we are reversing the result so to get the appropriate result and simply returning it. So this is the code where we have tracked each step line by line and have written the code successfully. Now what will be the time complexity for this approach? So here we are running a while loop which is O of n, and here we are running a while loop again O of n, same loop O of n, and finally we are trimming the zeros. Now in the worst case scenario, if we have only zeros in our result, then we need to trim the whole result, right? So time complexity for this will be O of n2, right? So the overall time complexity generated is O of n. And what will be the space complexity? So apart from taking any variables, we didn't use any additional data structure, right? This string we needed to carry, this string we needed to create because it was expected from the problem. So the space complexity for this will be O of 1 since we are not using any extra data structure. So I hope you guys like this video. If you guys really did, then please like, share and subscribe. It will really motivate me to bring more such content. If you have any doubt at any point, please comment it down. I'll try to reach to you as soon as possible. And if you have any feedback for my teaching, please comment it down too so that I can improve on it. So see you guys tomorrow solving any other coding problem. Till then, stay safe, stay happy and peace.